Okay, Assalamualaikum and hi everyone. Alright, so hari ni saya akan menggunakan bilingual atas permintaan ramai. Okay, today I will going to discuss about the second subtopic for chapter reaction rate, and that is collision theory and transition state theory. Right, so these are the things that you should know. First, you have to explain what is collision theory and then define activation energy, explain transition states theory, and draw energy profile diagram of a reaction. Right, so first we look at the collision theory. So collision theory can be defined as the theory to explain the rate of chemical reaction. So it is based on the rate is directly proportional to the number of effective collision, which means as the number of effective collision increase, so rate of reaction also increase. However, rate is inversely proportional to the time. Right, so which means that the faster the rate of the reaction, the shorter the time taken for the reaction to occur. So, and the collision theory also is based on the ideas that molecule must collide to react. So, dia mesti berlanggar untuk bertindak balas. And then, collision involved is an effective collision. Mesti pelanggaran berkesan. So, molecule must possesses a certain minimum kinetic energy, or also known as activation energy, to initiate the reaction. Mesti ada at least minimum energy, okay, for the reaction to start. And then molecule must collide in the right orientation, so for the reaction to occur. So ni dua syarat dia lah. Dua syarat supaya collision to become effective collision. So untuk menjadi pelanggaran berkesan. These are two requirements of effective collision. So first is minimum energy. So minimum energy here is referred to the activation energy, or the short form here is EA. So we can define activation energy as the minimum amount of energy required to initiate a chemical reaction. So which means molecule must have a minimum energy for the reaction to occur, to start. In conclusion, EA is actually a barrier that prevents less energetic molecule from reacting. This is analogy for the activation energy. Right, so imagine a boy want to push a rock over the hill. Okay, so the hill here is referred to the activation energy barrier. Right, so of course the boy takes some energy to push the rock up to the hill, which means a minimum energy is required to initiate the reaction. Once the rock is on top of the hill, so it will roll down the other side easily, okay, and then produce a product, okay, which means that reaction gets going spontaneously, release energy as it get moved to the lower state. This is higher state, this is lower state of the potential energy. Correct orientation. So let's say reaction between molecule A and molecule B. So in correct or proper alignment. Right orientation, proper alignment, correct orientation is the same meaning. So let's say in this position, so when both of the molecule collide, so it will produce an effective collision. So in the correct orientation, it will produce effective collision, and then it will produce products. However, both molecules react together but not in correct orientation, so improper alignment like this. What would happen? So it will produce ineffective collision. So the molecule will collide, but because of not in the right orientation, so it will produce ineffective collision. As the result, there is no product form. So it remains as reactant. Okay, so remember, there is two requirements for effective collision to occur. First, molecule must possess minimum kinetic energy, so which refer to the activation energy to start the reaction. And then second, the molecule must collide together. However, it must collide in a correct orientation like this. in order to form the product. Alright, so transition state theory. So we can define transition state theory is the configuration of the atom of the colliding species at the time of the collision. So maksudnya dia berlaku semasa pelanggaran tu masa pelanggaran tu, and then molekul dia akan susun dalam susunan, configuration susunan tertentu, tapi dia hanya seketika saja. Contoh like this. Okay. For example like this, we have AB. Ni AB molecule. This is also AB molecule. So when collide together become like this, dia akan dapat susunan atom macam ni pada waktu tersebut. Okay. And then lepas pelanggaran dia akan produce AA dengan BB. We do AA and BB is the product. Okay. Alright, so activated complex species form at transition state. So maksudnya spesies yang terhasil yang ni. Spesies yang produce kat sini, kita panggil dia activated complex. Alright, next energy profile diagram. So actually is a reaction profile show potential energy plotted as a function of the progress of the reaction. So the difference in potential energy between the product and the reactant is delta H for the reaction. Certain molecules must have enough kinetic energy to overcome the energy barrier, separating product from reactant. Okay, energy barrier here is referred to the EA, activation energy. So we have two energy profile diagram. So first here is referred to the exothermic reaction. So as we already know, exothermic reaction, which means reaction involve release energy from the system to the surrounding. Alright, so as we can see here, potential energy for the reactant is higher than the product. Okay, as the reaction proceed. Okay, progress. Okay, from reactant to the product. So we can see that the activation energy is here. This is activation energy. And the difference between the potential energy of the product and the reactant is somewhere here. Kat sini. So this is what we call delta H. So this is the activation energy. Right, so for the endothermic reaction occur the energy absorbed from the surrounding to the system. So we can see that the potential energy for the reactants is lower than the product. And then the activation energy is from the reactant here to the top of the graph. So this is activation energy. And then difference between the potential energy of the product and the reactant here is what we call delta H, which refer the energy is absorbed. Okay, delta H here is positive. Whereas for the exothermic, the delta H is negative. Show that energy release. Right, so this is the real example. Let's say we consider the reaction between CO, react with NO2, produce CO2 and NO. So this reaction is reversible reaction. Alright. So, we can see for the exothermic reaction, the potential energy for the reactant is higher compared to the product. As the reaction proceeds, the reactant should have at least this minimum energy to initiate the reaction to occur. If the reactant achieves the minimum energy, which refers to the EA here is referred to the forward reaction, which means from the reactant produce product. So it will form activated complex at the transition state, which means the fatty collision will occur and the atom here it will arrange in this configuration. So this is what we call transition state, and the product form here is what we call activated complex. It will produce the product which refer to CO2 and NO. If the reaction move reverse direction, meaning that from the product produce reactant. So here is the EA for the reverse reaction. Okay. And then difference between the potential energy of the product minus potential energy of the reactant. So we will get the delta H value. And the delta H value here, it will become negative value, which means energy release. Right, so for the endothermic reaction, let's say we have 2NOCl produce 2NO plus Cl2. So this reaction is also reversible reaction. We can see that the potential energy for the reactant is lower than the product. So as the reaction proceeds from the reactant to the product, so the reactant should have a minimum kinetic energy to initiate the reaction to occur, which refer to the EA. So this is EA for the forward reaction. So at this state, what we call transition state, the effective collision will occur, and then the reactant here, it will arrange themselves in this configuration, okay, dalam susunan ini. So this is what we call activated complex. The product formed at the transition state. Alright, so next, when the reaction proceed, okay, so it will produce NO and Cl2. So maksudnya activated complex ni hanya sementara sahaja. Okay, dia nampak seolah-olah macam satu molekul dia combine. So we can see that we have dotted line here. What is the meaning by dotted line here? Alright, so we have NOCl. Okay, and we want to produce NO and Cl2. Alright. Okay, 2NO plus Cl2. Okay, meaning that it involve bond breaking. At the same time, it will form bond making. So here is the bond making. So between Cl. So here involve bond breaking between N and Cl. Between N and Cl here also bond breaking. Occur at the same time. For the endothermic reaction, because the potential energy for the product is higher than the reactant, so the value of delta H here will become positive value. Okay? Alright. Okay, now we move to the question, sample question. Draw a potential energy diagram for an exothermic reaction. So the keyword here, exothermic reaction. In your drawing, you have to indicate the potential energy of the reactant and the product, activation energy for the forward and also the reverse reaction, and the heat of the reaction, which refer to the delta H. So this is the sample answer. So because this is exothermic reaction, therefore the potential energy of the reactant is higher compared to the product. Then you have to label like this. Because in the question here, does not give the equation. So you can just write in general. So this is just label reactant. And this is the product. And then you have to draw the curve line here to show the activation energy and the label. So, okay, from the reactant to the top of the graph here is referred to the EA for the forward. Okay, and then draw a dotted line. Okay, for reactant here and also the product. So you have to draw the arrow from the difference between potential energy of product and reactant. So this is referred to the delta H. The blue arrow here is referred to delta H, and you have to label negative. Delta H equal to negative because this is exothermic reaction. As for the EA for the reverse is from the product here. Okay, I draw arrow until reach the top of the graph here. So this is referred to the EA for the reverse. And then don't forget to label y-axis is potential energy. And then for x-axis is progress of reaction. Alright? Okay. Next question. So example number 2. For the reaction A plus B produce C plus D. Right, the enthalpy change, which means enthalpy change here is referred to the delta H of the forward reaction is positive 21 kilojoule per mole. Okay, and then it's already given activation energy EA for the forward reaction is 84 kilojoule per mole. Then you have to sketch reaction profile of this reaction. Reaction profile here is referred to the energy profile diagram. And then you have to calculate what here is you have to calculate what is the activation energy for the reverse reaction. Right, so this is the sample answer. So right. Okay, because given in the question, enthalpy change which refer to delta H is positive value. So this reaction is endothermic reaction, which means that the enthalpy of the reactant is lower than the enthalpy of the product. The potential energy of the reactant is lower than the potential energy of the product. Okay. And then you have to draw the curve to show the activation energy and then label lah. So, from potential energy for the reactant to the top of the graph here is referred to the EA for the forward reaction, that is 84 kJ per mole. Difference between the potential energy of the reactant and the product here is what we call delta H, or another name here is enthalpy change or heat of reaction. And the value here is positive 21 kJ per mole. And then one more, you have to label the EA, since so question B asks about activation energy for reverse reaction. So you have to draw arrow, okay, from the potential energy of the product to the top of the graph here is referred to the reverse, EA for the reverse reaction. So this is a calculation, which means EA for the forward, okay, minus delta H, ini tolak ini, dapatlah kat sini. So 84 minus 21, then you get 64 kJ per mole. Okay, that's all for today. Thank you and Assalamualaikum.